Hey everyone. In this video we're going to talk more about perceptions, and there's kind of a big one missing right now, and that's sound. So in a stealth game, right now he would not detect me whatsoever, no matter how much I sort of run around and, do whatever. He's not going to detect me until he sees me. So we need some kind of sound, hearing perception. I think that's the next big thing that we need to add. So that's what we're going to do. I want to make it based on things like speed and that kind of stuff. Really specifically, I want some kind of basic curve for how fast the player is moving. We can just make it a simple linear curve or something, just so that if the player is moving very quickly, they're almost certainly going to be detected within a particular range. And if they're moving slow, then they may never be detected. So it's really going to be about speed and distance, I guess, are the two. And so if I play this again and I pull this out, here, these spheres that I've created, I think, as I've mentioned before, these are going to be the maximum ranges of the perception for these guys. So this sphere that we're looking at here is the absolute maximum range that this particular guy is going to be able to detect anything, and that includes hearing and any kind of like sound or anything like that. My core design for this is going to center around a component. Now we could do kind of what we've been doing already, what we've been doing thus far, which is just grabbing the player and dealing with that. And I think that's the wrong thing to do, especially for things like noise. Now, arguably we could go in and change all the vision stuff if we wanted to, and we may do that, but for now I'm going to leave that, and we're going to do it kind of like more of the right way for sound. And it's getting into a little bit of architecture stuff, but I think this kind of stuff is really important. Remember that what you're trying to do is mitigate design change. And what I mean by that is if a designer, or you, if you're the designer, come forward and say, I think I want to add this to the game. Well, how easy is it to do that? So if we set this up so that the player is always the one that we're looking at to say, oh, how close is the player, how fast is the player moving, and so on, well, that means that if we want to add something else that makes noise to the game that can distract guards, we now have to maybe copy and paste a bunch of that stuff or do something like that. What I propose is that we have a component that we create that's called a Noisemaker, and we place that on the player, or whatever we want. We'll start with just the player, and that component is the thing that the AI interacts with. So the AI doesn't even know whether it's the player or anything. It just knows that it's an actor. Really, it just knows it's a component and says, okay, this component I need, tell me how much noise you're making, and then the guard will just respond based on how much noise that thing is making. This is very important in things like stealth games, right? This is from Thief, which was a series of games. Thief, The Dark Project, and Thief 2, and there's been, I think, 4 total now, maybe 5, because I think there was a mobile one that I never saw. But anyway, they have these Noisemaker Arrows, and this is common if you've played any of these types of games. Horizon Zero Dawn has this with, just tossing rocks, and you can kind of see, probably can't really see these animated GIFs all that well, but here they are. You can distract a character by shooting one of these metal arrows, and then they'll think they've heard that noise, and so they'll go over there and try and investigate, like, what was that? And now he's not looking at you, he's kind of going over there. So it allows us to say, okay, well, this is how noise reacts to our game. This is how characters react to suspicious noise in our game, and that's really what we're trying to make. All right. So how do we go about doing that? Well, the first thing we need to do is we need the component itself. So the component is going to be I've actually already built it, in that I've created a component. It's here along with a lot of other things. Where is it? So I just have noise generator, and I have nothing in noise generator. It's a blank component. So we can add whatever we want to it. Here under blueprints, the first person shooter blueprints, we have first person character. And I've already added on the first person character a bunch of things, one of them being the noise generator itself. So this is the noise generator on the character. So I've already added this component, so I've kind of done that part because that part's not interesting. The part that is interesting is the actual question of, how much noise are we making and at, what distance essentially. So that's the next thing that we want to look at. So the way that this is going to work is it's going to be essentially an interface. Like it's going to be a function that we're going to call on this node. In fact, there's not going to be any begin play or event tick. There's nothing here. What I'm going to do is I'm going to add a function. And I'm going to call this, get noise. What's a good word for it? Maybe get noise amount. Get noise distance. That doesn't seem right because it's going to be a bunch of different things. I'm going to say get noise amount. That's fine. Get noise amount. So this is the function. It takes nothing. It just is going to return a bunch of stuff. Mostly this function is going to be math. So tuck in. Here we go. I want to get the owner. So inside of a component, I guess I'll just do it like this then. Get owner. There you are. So inside of a component, I can get the owner. This is the actor itself. And in this actor, I want to get the current velocity. So this is going to be the velocity that we're going. So velocity is a vector, which is moving in the direction that we're going and has the length of the vector is going to be determined by the actual speed that I'm going. And so what I want from this is I want the vector, where are you? There you are, vector length. So I want the length of this vector. And the length of this vector is my current speed in units. And so we're going to create this little I don't really want to drag this around everywhere, so I'm going to create a little local variable here. And we're going to change this to a float. And we're going to drag it over here and say set current speed. And so the first thing we're going to do is we're going to basically calculate our current speed. There we go. And I like to sort of comment all this stuff. So we'll say, calculate current speed. So this is the speed that the player is going. Now what we want to do is we want to figure out how fast something is. And this should work, but basically we want to grab get owner. There's a component, there's a character movement component. Get component by class. And we want to find the character movement component. We want to find the character movement component. Now this return value may or may not be valid. Right? If it's an arrow or something, or maybe it's a thing that I just toss down and it starts emitting noise, so maybe it doesn't have a character movement component. And there's a bunch of ways that we can solve this. For now, what I'm going to do is I'm going to say if this thing is, not equal to null, then we'll do the thing. So let's go here. Grab this guy, not equal to null. So again, we're going to grab the character movement component, compare it to null. If it's not null, then we can go ahead and let's go here. And we can grab this guy and say, I think it's just get max. There it is, get max speed. There's a modified max speed, which we'll look at in a second. Okay, now that we have our max speed, we can start doing some of the calculations. One of the questions is, what do we do in the false case? So we'll just stick that in the back of your mind for a minute, where we have to deal with that false case. Now, once we have this max speed, what we want to do is we want to see how fast are we moving. So we want to have some kind of minimum. Maximum speed. Like we want to have some range in which we are completely silent. This is kind of a game design thing. So if I go here and I plot as some kind of curve, if this is our speed going up like this, some point along this curve here, we want to say that we are completely silent. That's a game design thing. You may choose not to do that. I am choosing to do that. So I'm going to choose to do that by having a little variable here. And this variable is going to be called, max silent velocity. That seems good. And so we basically want to do a lot of these checks if, let's see. So I'll grab this here and do a get. And then I want to say less than or equal to. And really it's this current speed. And I actually want to do this the other way around. So I want to say if our current speed is less than or equal to our maximum silent velocity. I'm going to pull these guys down here because I need another if statement, if. And this true branch comes out here. And I think I'm going to move this stuff kind of up here, and this is sort of its own thing. And we'll go through all of this stuff again and kind of review it. But we want to say if the current speed is less than or equal to the maximum speed, then we basically say that we're under our maximum speed and our value is 0. In fact, that means that if I click on this guy, I have to compile you. I want to, here we go, I want to add an output, and I want this output to be a float. And this is essentially going to be our, I'm going to say our noise value. All right, and so let's drag this guy here. I'll zoom this guy way out. Drag this guy over here. Zoom this guy kind of back in. Okay, so in this true case, we're going to return true. And so what I want to say here, and I'll just comment this guy, is check to see if we're moving slow enough to be completely silent. Okay, that's it. Now we need this false case. And in this false case, what we want to do is we want to do what's called calculating a normalized speed. Okay, I've sort of been avoiding this, but here's a little bit of math for you. This is very common in games and just in mathematics. There's this concept called normalization. Normalization. In math, normalization, a normalized value is a value from 0 to 1. And that's a really powerful range of values. And I'll explain why in just a second. The calculation for it is very easy. It's value divided by the max value. That's it. So if the maximum that I can have, say, is let's use bullets or something, is 250, and I currently have 71. Well, we can go here and we can say 71 divided by 250 is 0.284. So 0.284. And this is the normalized value. Now this is really, really powerful in a lot of different ways because it acts as a percentage. Because I can take anything else, any other number somewhere, and I can multiply it, or I can say a percentage. Because another way to say this, and this is maybe stirs some deep, dark memories, if I want to convert this to a percentage, I can essentially multiply it by, 100, or more, I guess not accurately, but more easily, I can just move the decimal point over here. So, in other words, 71 is 28.4% of 250. And again, it's a really powerful thing to say. How much health do I have, as a percentage? And so that now it doesn't matter. right? So I can say, if this is one weapon, I'm just using weapons because it's kind of easier. If this is one weapon that has a maximum ammo of 250, and I have 28.4, and maybe I have a rocket launcher that has a maximum capacity of 25, and I have, a much lower value, like, say, 20, well, we can go back to our calculator, and we can say 20 over 25, 0.8. So this guy is 0.8. Oh, I'm drawing in black. 0.8. Or this is the same as 80%, because if I move this over 2 spaces, that's 80%. So which has less ammo right now, right? I mean, this guy has physically less ammo, but I'm at 80% for my rocket launcher. I'm at 28.4% for my machine gun, or whatever this is. Okay, so this is powerful. And a lot of times in AI, normalized values are king, right? Normalized values are used constantly in various types of AI. And, I'm not going to get into huge detail on things like utility theory and that kind of stuff, but they are a very, very common value. And there's many other benefits to them. So we're going to use a normalized value specifically. Okay, so if I cancel this, what I want to do is so if we get to this false case here, we know that we're not completely silent. We know that we have this movement component here. So now what we need to do is we need to calculate a normalized speed. So the way that we do that, and I'll just kind of come down here and calculate it. So I want to take current speed, which I've calculated here. So we'll grab the current speed. I want to take my max silent velocity, and I'm going to need to subtract these guys from each other, because I'm trying to create a range. So you'll see in a minute. In fact, I sort of just thought of this. It would probably be easier. This is one thing I hate about Blueprint. Blueprint is a really amazing and powerful thing, but in my opinion, it's difficult to use for mathematical formulas, because you're creating this like your mathematical formula looks like this, and it's like all these things all connect together, and it just looks messy. Whereas I would much rather write an equation, and that's going to look a lot cleaner. I actually think, I don't know how you do it cleanly, but it would be really cool to have some kind of like equation node where I could literally type in an equation. That would be kind of cool, but I don't have that. What I want to do is I want to take my current speed, and I want to subtract my max speed, my max velocity that I've calculated. And I want to take this whole thing and divide it by another sort of subtraction thing, right? I need to take my max velocity and subtract it from this max speed that we just got, basically. And when I say max speed, it's sort of confusing these. Hold on. What I mean really is max silent speed. This is what I actually mean. Because down here I'm going to use max speed, the actual max speed, minus the max silent speed. And I'm going to divide these together. And then I'm going to take this whole thing, I'm going to basically clamp it. And I'll just kind of do it as a drawing. And I'm going to clamp it between 0 and 1. And clamping is a little heavy-handed, but it works. So what is this actually doing? So my max speed minus the max silent velocity. Okay, so I deleted my curve, but if we look at, I guess I'll do it as kind of a little box. I have this little box here, and this represents all of my stuff. So this is my max speed. This is 0. And somewhere in here, I have my max silent speed. So what I'm trying to do is I'm trying to get a range where my 0 to 1 value is from here 0 to here 1. I want to use this value. I don't want to include this at all. So this is what I'm trying to do. So I take my current speed, and for the sake of argument, we'll say that my current speed is here. So I'm taking this current speed and subtracting out basically this thing. I'm taking my max speed and I'm shifting it down by the same amount, right? So it's going to be down here somewhere. I'm shifting it down to about here. So I'm saying, where in this thing am I as a percentage? So that's the purpose of what I'm doing here. Okay, so now let's go back here and let's actually write this thing. So over here, it's this max speed. Where's my thing? Reroute node. Drag this guy over here. I feel like there's a hotkey to change the reroute node. I don't remember what it is. Okay, and so you are here minus float, and I need my max silent velocity again. Uh-oh. You're not max silent velocity get. Drag this guy up here. There we go. And we can pull this guy over here. And then these guys are divided. Vector. Oh, not vector. Float over float. These guys are divided together. And then just in case, if I happen to go a bit over or whatever, just so that the math doesn't break, we're going to do a clamp. And I actually don't know that we need this. But we're going to do a clamp between 0 and 1. And then that's it. I think we want a maximum noise distance. So if I go back out here, I don't actually know if I can play this again, because I might be in kind of a bad space. But you saw that I had the sphere here. I don't think I actually want that. I want those to be able to change independently. I can usually see somebody a lot further away than when I can hear them. So I want to create that. And I think it's just, right now, I mean, we could do something really complicated, but I think it's simple enough to just say, max noise distance. This is the maximum distance that this noise is going to travel. Both of these I feel like are tunable. And so max noise distance, we're going to take max noise distance here, and we're going to multiply these. And this is part of the power of normalized values. The max noise distance multiplied by this normalized value. We know by definition that this normalized value is never going to go above 1. So we know that at best, it's going to be 1 times my max noise distance. So if my max noise distance is, for simplicity's sake, 100, then I know that the maximum that this is ever going to be is going to be 100. And I know what the minimum is going to be is 0, because it's 0 to 1. So if I go back to this curve, and I'm halfway down this curve, just again, for simplicity's sake, I'll delete this and add it again. I am here. So I'm halfway between my max silent and max speed. This, or specifically this, is going to be 0.5. And so my max noise value essentially is going to be 0.5 times whatever this distance is. And that's my value. And that's what I'm returning. I think I can just do return. Nope. Can I do it here? Add return node. There we go. There. Okay, and this is actually the false case. So I'm going to clean this up a little bit. This is kind of ugly right now. We'll do something like this. We'll pull this guy up a little bit. These things can get really out of sync, and it's really worth spending the time to kind of make this better. And we're going to comment this stuff a little bit. I'm going to kind of go through this, and there's a couple things we're missing, specifically this guy. Okay, so we have this. We calculate our current speed. That's easy enough. Down here, the next thing that we're going to do is we're going to grab the movement component, and if we have it, we're going to do a bunch of stuff. The problem is, what do we do in this sort of false case? So we don't have a mover component. It means we can't have a velocity or a speed or anything like that. What that really, I think, means to me is that it's going to be based entirely on things like how far away am I, the distance, and stuff like that. All of our calculations right now are based on speed, and I think that's okay. And in fact, I think I might rename this to get noise distance. It's sort of a calculated distance. I don't know if there's a really good value for this. So in this case, if we can't move, we can't have any kind of speed or anything, I think maybe we return 0, similar to here, to see if we're moving enough to be completely silent. We have to figure out what this is going to mean. For now, I'm going to say add return node here. I'm going to have it return 0. And what I would normally do in kind of a game like this is I would say, to do, figure out what to do if there's no character movement component. Hit enter, and of course we're going to expand this. I'm going to expand this a little more. So I'll write this little to-do node. And again, some kind of best practice, like figure out some of the colors that you want to do. Because this feels like a really good place to have, some kind of like yellowish color. It seems fine. It's like, hey, call your attention to this. We should probably figure this out. For now, I'm not going to worry about it. For now, it's only going to be on the player. Okay, and then down here, we're going to actually calculate the normalized speed. That's really what this is. So calculate normalized speed. I'm going to talk about philosophy for a little bit. For better or for worse, and especially if there are programmers watching me, calculate final noise distance. This is probably fine. Especially if there are programmers watching me, they may disagree with me, and that's fine. Neither side is probably totally correct. My general philosophy, I should comment this chunk too. I'm going to actually say calculate movement speed. My philosophy in commenting in any code, whether it's C++ or C# or Blueprint, is in general, I should be able to tell what a function or whatever is doing just by reading the comments. It doesn't have to be perfect. It doesn't have to be exact. I should generally be able to tell with the comments, calculate current. Okay, so first we calculate current speed, then we calculate the movement speed. This branch is a to-do. Okay, check to see if we're moving slow enough to be completely silent. Good. Okay, calculate the normalized speed. Calculate the final noise. Great. I can generally follow what this is doing as I walk through this. And that's my philosophy. Some programmers disagree. They think that that's over-commenting, and I disagree with them. So, the real thing to do is look at both, look at code from both, work in systems where people are, doing my style of commenting, and look at systems where people are doing a more or a less verbose kind of commenting, and see which one you prefer and make your own choice. Because I don't think anyone's right. I think it's just preference. The two major schools of thought I've heard with commenting are comment basically every paragraph of code, and the other one is comment only when there's some exception that someone has to care about. So I much prefer the former. I comment every block for the most part. Now, I promised I would get back to this get max speed, because there's, if you type in get max, there's this get max modified speed. And I'm going to kind of dig on Unreal a little bit. Because if you search for it, like character movement component, Unreal 4, get max modified speed or whatever. Like if you search for this, I've done a bunch of searches for this. There's like these tutorials and stuff. And I just couldn't find anything about this or what the difference between these things are. I just could not find it anywhere. So this is so I figured it out, right? I mean, what I ended up having to do is I had to go into the code. This is the C++ code, and I started here at character movement component, and I just sort of like looked for it. It wasn't anywhere, and I just kept walking up this inheritance chain. And I'll zoom this in a little bit for those who are interested in kind of seeing what's here. This is the C++ code of Unreal. This is one of the things that I love about Unreal over engines like Unity. Because in Unreal, I'm looking at the engine code. Here it is. In Unity, I wouldn't be able to figure this out unless it was in the documentation. I did have to go all the way up to movement component, by the way, which is almost at the top of the tree. There's an actor component. So it's basically the top of the movement tree. And I found it. Here it is. Or wait, where did it go? Get modded. There you are. Get modified max speed. It's this guy. Oh, here it is. It's this guy. And so you see this. So here it's here, but it's deprecated. As of 4.3, which was quite a while ago, get modified max speed is deprecated. Use get max speed instead. So there it is. Don't use get modified max speed. But it is kind of funny that I had to like dig into the engine to figure out where it was, and I haven't found any documentation on it really. So it's a love-hate relationship. I wish the documentation were a little more up to date or a little better. But at least with Unreal, I can go in and I can literally look at it. Here it is. Get modified max speed. It is a deprecated function. Don't use it. That's it. Okay. So this should work for our little component. This will hopefully give us this little function call that we can use. So the next thing that we have to do is we have to actually write this. So that's where we'll end for now. And next week we'll actually implement all of this stuff. We'll hook it all up to the AI and all that kind of stuff. But for now, I think we have a pretty good noise generator component. Okay, see you next time. So that's where we'll end for now. And next week we'll actually implement all of this stuff. We'll hook it all up to the AI and all that kind of stuff. But for now, I think we have a pretty good noise generator component. Okay, see you next time.